So on our most recent Google Meet, we did a Nearpod where we took an equilateral triangle, figured out a bunch of stuff about its angles and sides, chopped it in half, and ended up with what's called a 30, 60, 90 triangle. And that's what we're going to be talking about in this lesson, along with another type of special right triangle. But we're going to start with 30, 60, 90 triangles, and hopefully you were at that Google Meet and have already learned about this a little bit. But if you have a 30, 60, 90 triangle, that's referring to the angles. So we have a 30-degree angle, a 60-degree angle, and then we have our right angle, which measures 90 degrees. And you'll notice on this picture here, the sides are labeled as x times the square root of 3, and 2x. So x is the shortest leg. And if you're ever unsure about which leg is shortest, usually you can tell. But if they haven't drawn the triangle to scale or something, always just look at what is across from the 30-degree angle. That's going to be the shortest leg. And here that's labeled as x. To find the other leg, the longer leg, which is the leg that's across from the 60-degree angle, you take your short leg and you multiply it by square root of 3. So that's why that is labeled as x times the square root of 3. The third side of your triangle is your hypotenuse, and that's the one that's opposite the right angle. And to find your hypotenuse, you take the short side, the x, and you multiply it by 2. So if you know the short side, you can multiply by the square root of 3 to get the other leg, and you can multiply by 2 to get the hypotenuse. Now, you don't always know the short side. Sometimes you're starting with one of the other sides. So we're going to look at a few examples that kind of go through some of the different situations you'll see. So here, on our first example, the side they give us is across from the 30-degree angle, so it is the shortest side, so it's 5. So we're going to, that's probably the easiest one to start with. So what we can do is we take the 5 and we multiply it by square root of 3, and that's going to tell us the other leg, which is the b. And then we would take the 5 and multiply it by 2 to find the hypotenuse, which is the longest side. So when we do that, our short side, they told us, is 5. Our medium side, our other leg, is going to be 5 times the square root of 3. And our hypotenuse is going to be 5 times 2, which is 10. So that's all there is to it if they give you the short side. On the second one here at the bottom, they give us the hypotenuse. 13 is the hypotenuse. I'm going to do each of these in a different color. 13 is the hypotenuse. We know that because it is opposite the right angle. So here we know that 13 is 2 times the shortest side. And the short side of this triangle is k. So 13 is 2 times k. So to find k, all we need to do is take 13 and divide it by 2. So if they give you the hypotenuse and you want to find the shortest side, just divide it by 2. And I'm just going to leave this as 13 over 2. If you wanted to divide that out, you would get 6.5. That's also correct. I'm just going to leave this like this. So k is 13 over 2. Once you know the short leg, you can find the other leg because all you do is you take the 13 over 2, the length of the short leg, and multiply it by square root of 3. And all you have to do here is put the square root of 3 on that fraction with the 13. So it's going to be 13 times the square root of 3 over 2. So that's all there is to it. So if you know the short side, you can just multiply by square root of 3 to find your other side, multiply by 2 to find the hypotenuse. If you know the hypotenuse first, start by dividing it by 2. That will tell you the shortest side. And then you can find the other leg by multiplying the short side by the square root of 3. One more example here on 30, 60, 90 triangles. Here, the side they give us is not the hypotenuse or the short side. It is the other leg, the longer leg, is 9 square root of 3. So here, again, kind of going back to what we know that 9 square root of 3 is equal to our short side, which in this case is m, times the square root of 3. We always multiply the short side by the square root of 3 to get the other leg. So for this to work, what we can do is just kind of divide the square root of 3 out. Get rid of the square root of 3, and what we're left with is 9 is equal to m. So for this to work, m has to be 9. So our short side is 9, and that makes sense because 9 times the square root of 3 would get us 9 square root of 3. Now the other side we have left that we still have to find is the hypotenuse, and we know to get the hypotenuse, we take the shortest side, which is 9, and we double it. So we're going to take 9 times 2, and that's going to give us 18. So our short side is 9, the other leg is 9 times the square root of 3, the hypotenuse is 18. So that's how you can find all 3 sides of a 30, 60, 90 triangle if you just know one of them. All right, the other type of special triangle that we didn't really, I think we got to this in one of the classes, but not in most of them, was the 45, 45, 90 triangle. So a couple things to notice about 45, 45, 90 triangles. First thing is, in addition to being a right triangle, because we do have a 90-degree angle here, they're also isosceles. You have 2 sides that are exactly the same. And we know they're exactly the same because of a rule we learned earlier in the year, is that if you have 2 congruent angles, so these are both 45, they have to be congruent, the opposite sides are also congruent. So we know if we have a triangle with 2 45-degree angles, the opposite sides also have to be the same length or the same measurement. So we have an isosceles triangle, so those 2 x's are the same. And if you look at the other thing we know about it, sorry, before I get ahead of myself, the other thing we know about a 45, 45, 90 triangle is it's exactly half of a square. So if you take a square has 4 right angles and 4 sides that are all congruent to each other. If you take a right angle, a 90-degree angle, and chop it in half, half of 90 is 45. So the idea is you take a square, you chop it in half diagonally, you end up with a 45, 45, 90 triangle. So if you look at how this is labeled, the 2 sides that are the same, the 2 legs, are both labeled as x. Remember, they are always going to be identical. And then the hypotenuse is x times the square root of 2. And I want to show you why this works. We're going to do a squared plus b squared equals c squared. So if we do that, a squared and b squared are both going to be x squared because our 2 legs are both x. So we have x squared plus the other x squared equals, and let's say we have no idea what this is yet. So we don't know the hypotenuse yet. We're just going to call it c squared. Okay, so when we work this out, we're going to have x squared plus x squared is 2x squared equals c squared. And then to figure out what c is, we have to take the square root. So we take the square root of both sides. So those cancel out. We just get c. So c is equal to the square root of 2x squared. Now here's how you break down a square root like this. You would break it up into 2 pieces, square root of 2 and the square root of x squared. The square root of x squared, we can simplify that because a square and a square root cancel each other out. And so we're just left with plain old x. Square root of 2, we can't simplify. 2 does not have a perfect square root. So we just leave it like that, as square root of 2. And that's what we end up with. So if you do a squared plus b squared equals c squared on one of these triangles, what you should always end up with is one of the sides times the square root of 2. And not to overdo it, but let's do this with an actual number. And so you can see how it works here. So let's say x is equal to 5. So let's say now these 2 sides are 5. And we want to find our hypotenuse. What we're going to do is we're going to take 5 squared plus 5 squared equals c squared. 5 squared is 25. We add those together, we get 50. And now we're going to take the square root of both sides. And we get c is equal to the square root of 50. Now, 50 is not a perfect square root. There's no whole number that you can multiply by itself to get 50. But we can break this down. The way we would break this down, kind of like we did on the last one, is you split 50 into two numbers. Split it into 25 and 2. The reason we do that is because 25 has a perfect square root. We can take the square root of 25 because it's 5. 2 does not, so it just stays where it is, and we end up with 5 square root of 2. So it works for 5, and it would work for any number. And the nice thing about this is if you didn't catch all that, you don't really need to worry about it, because for any number, all you have to do to go from one of the sides to the hypotenuse is take that side and multiply it by the square root of 2. So whatever number you have for x, just stick square root of 2 after it, and that's going to tell you the hypotenuse. But let's go ahead and look at a few examples of these. So on the first one, we have a 45, 45, 90 triangle. It's turned on its side, but it's still a 45, 45, 90 triangle. One of our legs is 8. So the first thing we know is the other leg has to be exactly the same. These two sides have to be the same. So if that's 8, that is also 8. And then to find the hypotenuse, all we have to do is take the 8 and stick a square root of 2 after it. And that's it. So we have 8, 8, and then 8 times the square root of 2. On the second one, we're going to go backwards because we're starting with the hypotenuse. So if we're starting with the hypotenuse and then figuring out what the legs are, instead of tacking on the square root of 2 or multiplying by the square root of 2, we need to get rid of or divide by the square root of 2. So what we're going to do is we're going to take this 1.2 times the square root of 2, and we're going to get rid of the square root of 2. We're going to cancel that out. And so our two legs are both going to be 1.2. So if you're starting with the legs and you're trying to find the hypotenuse, you multiply or you tack on square root of 2. If you're starting with the hypotenuse and you're trying to find one of the legs, you divide by or get rid of the square root of 2. Last example is a little different because it gives us one of the legs, but this time the leg has a square root of 2 in it, which is kind of weird. We haven't really seen that. So the first part's the easy part. If this leg is 6 square root of 2, the other leg also has to be 6 square root of 2. Those always have to be the same. Then to find our hypotenuse, we need to take our leg, 6 square root of 2, and multiply it by the square root of 2. So I'm going to do that off to the side here. Take 6 square root of 2 and multiply it by the square root of 2. Now when you do this, here's what's going to happen. We have a 6, and then square root of 2 times square root of 2. You can combine those into one square root and put the 2 times 2 under that one square root. 2 times 2 is 4. So this becomes 6 times the square root of 4. Square root of 4 is 2. So this becomes 6 times 2. And now 6 times 2 is just 12. So the quick way to do this is whenever you have a square root of a number times the square root of the same number, it always just gives you that number. So square root of 2 times square root of 2 is equal to 2. If you had square root of 3 and square root of 3, that would be equal to 3. So that's how you would do that. If your square root is not on the hypotenuse, if it's on one of the legs, you still multiply by square root of 2. That will cancel out your square root and give you a whole number. And in this case, you end up with 12. So that is special right triangles, your 30, 60, 90, and your 45, 45, 90.